My name's Ted Rozier. I am the Director of Digital Advanced Technology and Robotics for Festo Didactic. When you look at Festo, a lot of people know Festo as a global automation manufacturing organization. So what do we focus on? Valves, cylinders, sensors, and electric drives. Another sector of our business would be the didactic group, and that's who I represent. That would be Festo Didactic. And we go into high schools, community colleges, and universities, and we provide educational training modules. So we're basically a system integrator for education. SICK is a leader when it comes to sensor technology. One of the things that we wanted to do is we wanted to make sure that when we go into the education space, in the classroom, there was one thing that we would focus on: safety, safety, safety. But our goal, Festo Didactic and SICK, we look to hone in on safety, risk assessment. But what is it that students are learning about true safety protocols? Are they learning the standards so that when they go and get employed, they're able to actually speak to the standards with conviction? And that's what we're looking for. Within education, as a system integrator, it's important that we provide a turnkey solution, and that turnkey solution would require that we have curriculum. So in the education space, content is king. And that's another reason why we really enjoyed working with SICK, because what we did in parallel to designing the safety awareness bundle, we also kicked off a curriculum team that would work together, where we would take safety standards, align them specific to the application, and actually teach students about the theory, knowledge check, and then a practical task. So what does the safety awareness bundle look like in the classroom? Well, when we think about the hardware side of things, there is a safety PLC, and then there's sensors that are connected to the doors. Now that would be for, you might say, a robot in a cage. So let's talk about that a little bit. I have a key here. As this robot is running, I'll go inside. All of a sudden the robot goes to an e-stop. You can see the actual safety PLC there. Of course, it's tied to the safety sensor, allowing for no redundancy. So what happens is, with the sensor being tied to the safety PLC, the sensor can't be jumped out. That's the key that the student should learn. Now, outside of that, there is a vision system tightly integrated into the robot, where we can pick from a palletizing grid, and we kind of scramble the parts, and the robot goes and picks those parts. But from a safety standpoint, what's very key here is that the student understands that with the safety PLC working hand in hand with the sensor, it cannot be jumped out. Therefore, you have true safety, just like in a manufacturing plant. So we'll go ahead and close the door here, reset, start that robot, and put him back to work. So now let's transition ourselves to the safety awareness bundle that incorporates area scanner. So you can see here that there is no cage around this robot. So a fenceless cart is extremely important when it comes to manufacturing space as well as education. But what are the things that we want students to learn? Well, SICK and Festo looked at the safety awareness bundle, and we wanted to put a spotlight on risk assessment. So when you look at the cart, first of all, you have two area scanners, one on each corner. So the one on the right-hand side here on my right would handle about 270 degrees of protection. Then we have another one that's on the front side that would handle 270 degrees. But what happens is now you have 360 degrees based upon how you tweak the software. And now we can actually give the robot eyes, and it's able to see. It's able to protect the human being as they start to work with the robot. What is it that the students are going to learn? Well, they're going to learn how to set up zones, first of all. As I approach the robot, you'll notice that the yellow light comes on for awareness that it's slowing down. But then as I get closer to the robot, it's going to go into an e-stop. As I back away, the robot now can resume. But how close should I be when I restart the robot? Based upon our curriculum and risk mitigation, the risk mitigation plan is to bring an arm out that would take me away from the robot. Now I can hit reset, cycle start, the robot resumes. And the student gets to walk through that within the curriculum, adding the risk mitigation box so they can start the robot in a safe position. But now we're going to look at the overall systems approach. Here where we would build a part. And what kind of part are we talking about? Basically, it's a 40 millimeter round puck that has a spring, a hub, and a cap. But what happens after the part is built, it then transitions to a palletizing grid. It also has slip sheets. So we would load 4 finished parts into the bin, and then we would take a slip sheet, put it on top, and then add 4 more parts on top of that. The overall systems approach and what's being taught here, of course, safety first, last, and always. So within the system here, you have actually 3 scanners. So you're picking up the side zone, the front, and also the right side. And we're capturing the rear. So we've integrated 3 safety sensors back to actually 2 safety PLCs. So the students have the ability to build up. They can basically break the system down and work on it robot a la carte. Then they can bring the 2 together with a small conveyor in the center. Again, working closely with SICK Safety, the programming and the control architecture, students are really getting an opportunity to really, again, going back to the light, we can shine a light on safety first, along with risk mitigation, having the risk mitigation arms, exactly what they would see on the manufacturing floor. Another topic that's being taught within this education training module would be an industrial robot that works side by side with a collaborative robot. Now, both robots have area scanners, so we've given eyes to all the robots. But this robot being a collaborative, I can reach in and basically stop it based upon force. So the student, in addition to learning about the area scanners and setting up the zones, they're also going to be taught how to set up the force in such a fashion where if that robot bumps into the student, it would then pause. Again, using my mitigation arm, we would reset and we can restart that robot. So we've gone from robotics a la carte to the systems approach. We've talked about collaborative robots, and we've also talked about how do we give the robot eyes. Through the area scanners, I want to show you the things that you can't see that's happening in the background. So you see there's a monitor here that would clearly show you the 2 area scanners, and you'll notice on the right side as I stand in front of the area scanner, you can actually see on the monitor where my legs are. So when setting up the zones, the warning zone and the e-stop zone, SICK has done a fantastic job in providing a very easy to use software package where you can draw in those zones. There could be a pillar, which would happen in a manufacturing plant. There could be all kinds of different obstacles that you can draw around to make sure that the robot is very safe and operates differently when a human being approaches it. Another principle that Festo and SICK aligned very nicely on in our partnership is the fact that we are vendor agnostic when it comes to robotics. All robots need safety. So we play very well with ABB, Fanuc, Universal Robots, as well as any other vendor. Safety first, last, always for all brands. So in closing, when you look in manufacturing today, as well as education, robots are selling at an all-time high, and safety has to be considered. If you're interested in teaching safety first in the classroom, make sure you bring SICK Safety with you. Don't hesitate to reach out to your local value-added reseller for Festo within the education space. We'd be more than happy to bring safety into your classroom. Safety first, last, and always.